Algebra 1, 2-5, absolute value equations. Okay, guys, absolute value is distance to 0. So I want you to keep that in the back of your mind, that absolute value is always distance to 0. And so absolute value is represented by vertical bars. So let's take a look at an example. This is going to be the first example in the text. We've got x plus 6, or absolute value of x plus 6, excuse me, minus 14. And they're going to tell us that they're going to give us an actual value of m equals 4. So we're just going to substitute in 4 plus 6 minus 14. 4 plus 6 is going to give me 10. So the absolute value, the absolute value of 10 is distance of 10 to 0, which is 10 spaces. So I'm going to eliminate the absolute value brackets and just end up with 10 minus 14, which is negative 4. Okay, absolute value of 10, which is 10, minus 14 gives me an answer of negative 4. Next example gives us absolute value of f plus 5 equals 17. It wants us to solve and wow, that's great spelling. But you know what, guys? It happens. How about let's solve and, got a little too early with that G, and graph. If we know distance is 0, we know that, for example, 5 is 5 spaces away from, I'm not going to use the number 5, I'm going to use the number 17 because that's what's in this problem. We know that 17 is 17 spaces away from 0. So we're going to want to find what value in there is going to give us a value of 17. But we also know that negative 17 has an absolute value of 17 because it's 17 spaces away from 0. So there are going to be two cases here. We're going to solve two problems. We're going to eliminate our absolute value brackets, and we're going to say that whatever's in that f plus 5 has to equal 17. But we also know that our f plus 5 could equal negative 17. So basically you're going to take the same equation, but just change the sign of the 17. So just a real quick, we did this last week. Let's subtract 5 from both sides. That's going to give us f equals 12. Then we're going to subtract 5 from both sides here. And that's going to give us f equals negative 22. Now let's set those back in there real quick. 12 plus 5 is 17. That gives me a distance away from 17. Let's plug in the negative 22. Negative 22 plus 5 is negative 17. And the distance from negative 17 to 0 is 17. So I know that these two will work. So now graphing them, I just need a number line. It's not a crazy graph, just a simple number line. And I'm not going to go by ones. I'm going to go by, let's see, I need to be at negative 22. 22. Oh, we can go by, let me erase that. Let's go by 4s, and let's start with 0 here. 4, 8, 12. I'm going to go one past. And so that'll be negative 4, negative 8, negative 12, negative 16, negative 20, negative 24. That way we don't have to make a huge line. And just to graph these, we're going to simply put dots above our solution. So we have a solution at 12, and we have a solution at negative 22. Okay, let's look at a special situation. I told you at the beginning that absolute value is distance to 0. So on every single problem, I want you to immediately look at the answer. In this case, this is a negative 8. Is there any way I can have a distance of negative 8? Is there any number that I can put in that absolute value that's going to give me a distance of negative 8? And the answer to that question is absolutely not. I can't get in my car and drive negative 8 miles. I can't walk negative 8 spaces backwards. There is no distance of negative 8. So if you see problems like these, green light in your brain will tell you right away, there's our symbol. And remember, that's the symbol for no solution. There's not a single number that I can put in an absolute value bracket to give me a distance of a negative number. So that's Chapter 2, Section 5, Absolute Value Equations.